Welcome to Pomodoro Joe for Thursday, August 24th, 2023. Today we're doing LeetCode problem 68, text justification. This is a hard problem. Given an array of strings, words, and a width, max width, format the text such that each line has exactly max width characters and is fully left and right justified. Oh, that means it's spaced evenly. Oh, like this, all right? You should pack your words in a greedy approach. That is, pack as many words as you can in each line. Pad extra spaces when necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on the line does not divide evenly between the words, the empty slots on the left will be assigned more spaces than the slots on the right. All right, so that means we have more slots on the left than on the right. Cool. For the last line of text, it should be left justified and no extra spaces inserted between words. So that means we have extra spaces at the end here, or we have one space and a whole bunch of extra spaces. Okay. Note, a word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0 and not exceed max width. The input array words contains at least one word. All right. This doesn't actually seem that bad. So let's put 25 minutes on the Pomodoro timer and we will get started. So it looks like we return a list of strings. So that's going to be, a list where each line is one element in our list. Cool. So we'll have some result and that'll start as an empty list and we will return our result at the end. All right, so let's just break this down into steps. I think the first step I'll have is let's just find all the words on a particular line. So for line 1, let's get all the words. And line 2, let's get all the words. Once we have all the words that fit on that line, then we can go through and space them properly. So we'll have two helper functions here. One is like get words for line, and the other will be get line with these words. All right, so let's just put in some helper functions here. So like get words for line, and we'll just pass in some line number. And for now, I'm just going to pass. We'll come back to this. So once we have the words for this line, we can create that line by using those words, and we'll basically have to develop the spaces or figure out the spacing. So def get line, we'll pass in the words, and again, I'm just going to pass. So this gives us our two helper pieces. Now let's go through and actually do the main engine part. So for every line we'll go through, we'll get the words for that line, and then we'll get that line with those words, and we'll put those in the result. So let's see, for, and this is where it kind of breaks down. I don't actually know how many lines there are. So let's see, let's make this up. Let's say we have some max line, and that will be, we don't know. So I'm just going to set it to 100. We're going to completely change all this. This is, well, maybe I shouldn't confuse you. Okay. I probably shouldn't confuse you. Let's not do that. So here's the idea. While we're not done, how about this? I'll do while not done. So we'll have some done equals false. So while we're not done, so we're still getting lines. Let's get the lines. So words for line. And that's just going to equal get word for a line, and we'll have to pass in some line number. But this is just, I'm just roughing this out. So words for this line, we'll just call our helper function, get words for line. And then we'll use those words to get the line. So our line will just equal get line, and we'll pass in these words for line. And now once we have our line, our result, we'll just append this line. And at the end, we return our result. Okay, so this is our very rough outline. So while we're not done, we'll just get words for some line. So we'll start at 1, 2, 3, 4. Once we get the words for that line, we'll create that line by calling our other helper function, and then we'll add that line to our result, and we return the result at the end. Cool. Now, we're going to make some changes here. We don't actually know how many lines we have. So instead of get word for line, passing in a line number, let's pass in maybe a start word or a start index. So get words for line starting at this start index. because we don't know how many words are actually going to be in that line. So if we had, let's say, get word for line 1, well, we know we can start at the first word, but we don't know how many words we're going to use. Then when we say get words for line 2, well, we don't know our start word unless we know the end word of line 1. So let's use some start and end index to indicate our current line. All right, so instead of having this while done is false, well, let's just do this. So we have some start index. We'll start it at index 0. We'll have some end index. That'll be index 0. So instead of saying get words for line, we'll say get words, and we'll pass in a start index. Or I could still call it get words for line. Let's do that, for line, starting at this start index. Okay, so now we'll do get words for this line starting at this start index. Now instead of getting words, let's just pass back the end index. So having a start index and an end index, that will tell us which words fit on this line. So instead of saying get word for line, we'll say get end index for line. All right, so let's change this down here. Get the end index for our line. And we'll have to pass in our start index. So start index. All right, and this will be returning our end index. So instead of returning a list of words, we're going to have a new end index. So let's see. Well, we have our end index here. Great. So we'll pass in our start index. We'll get a new end index. Then this get line, we're not going to pass in a list of words anymore. We're going to pass in our start and end index because those define our list of words. So we'll have a start index and an end index. All right, so our get line here, instead of passing a list, we'll have a start index and an end index. Cool, I like this a lot better. Okay, so we're going to get the end index for a certain line starting from some start index. Then we'll get our line based on that start and end index. Then we'll append the line to our results. So that doesn't change too much. We don't need this done anymore. So when are we done? I guess we're done when our end index is greater than the length of our words. Well, let's get a last index here. That's going to help us out. So last index, that's going to be the length of our words minus 1. So that's the last index. Okay, so while our end index is less than or equal to, I think, our last index. Let's see. Do we want it less than or equal to, or we just want less than? If it's equal to the last index, we still might need to include that word. So it's less than or equal to. All right, now we have to get to, one more thing. Now that we have our end index, we'll need to update our start index for the next loop. So we'll append our line to our result, but now our start index becomes our end index plus 1. We're going to start at the next word. And we might want to update our end index here, so end index doesn't come before start index. So we could also do end index is equal to our start index, just as we did here. But we could also do that inside here. Well, let's do it out here just to be safe. Our end index should never be earlier than our start index, so it's going to equal our start index. All right. Now we've got our framework. We've got to fill in these helper functions. Get end index for line. Okay, so how do we determine the end index for a line? Well, we'll just go through and pack as many words into this line as we can. So we'll have to keep track of our words and their character count. All right, so let's have some end index here. We'll set it equal to our start index. And we'll return the end index at the end. All right, now we'll also have to keep track of our character count. So I'll have our character count set equal to 0. We have no characters yet for this line. All right, now while our character count is less than our max width, we can keep adding words. So while our character count is less than our max width. Let's see, should it be less than or equal? Less than and equal to. Well, if it's equal to the max width, we can't add any more characters, so we shouldn't continue our loop. So it's just while the character count is less than our max width. And we also have to make sure that we don't go outside the bounds of our word array. So, and our end index has to be less than or equal to our last index. If it's equal to the last index, we can still add this word. Okay, so now let's add this word to our line. All right, so our character count will increase by this word at the end index by its length. All right, so we're going to add this word to our line. So that's going to be increasing our character count by the length of the words at the end index. And then let's see, we do need to have a space between all of our words. So let's add an extra 1 for our space. So we'll have our word, the character count for our word, plus the space between our words. So we'll add this extra character. Okay, so we'll keep doing that, and then we have to increment to the next index. So end index plus equals 1. So we'll grab this word, add it to our line, and then we'll increment our index so we can go to the next word. As soon as we have too many letters in our line, we'll break out of this loop. But we have to do a little bit of fix up here. So we've determined that our character count is greater than or equal to our max width. So at this point, basically we've added it here, we've gone on to the next word, then we break out of our loop. So we've sort of added one extra index after we've broken. So we actually need to roll back this index. So we have to do end index minus equals 1. So we roll that back. And then I guess technically we've added an extra character here because our last word, we don't want to put a space after it. So we actually have to roll that back too. So our char count minus equals 1. Cool. Now, do I have any edge cases to consider? Well, for most lines, I think this is fine. Oh no, there's still one more edge case. So it's possible that we broke out of this loop because we are greater than this max width, which means that this end index might still be 1 too far. So if we go through, we are adding some word. So this last word that we added, so we added some last word, then we incremented our index. Then we found out, well, that's too far. So we've rolled back our index to that last word that we added. But even adding that last word might be too far, might exceed this max width. So we might have to roll back our end index 1 more. So let's check that here. If our char count at this point is still greater than our max width, then we have to roll back our end index 1 more. Okay. Now, is it less than or equal to? No, I think it's greater than. So if we're equal to the max width, we should be fine. Wow. Okay. So this should give us all the words, or the end index, which will determine all the words for a single line. Once we have that single line, we'll have to go through and create that line. So let's see. Should we... We don't have a lot of time. Normally I'd probably do a debug print here and just run it just to see if I'm getting the right indices. I don't have a ton of time, so we're just going to keep going. Then we'll go back and debug probably if we have problems later. Okay, now we've got our get line. So we figured out which words go in a particular line. Now we have to determine how to space those words out on a particular line. All right, so let's start with some line, and it's going to be an empty string to start with. And we'll return our line at the end. Okay, I'm spacing this out just to give it a little bit of room so you can see it better. Now, how do we determine our spacing? Well, if we know how many words we have on a line, then we know how many spaces between words we have. So if we have 2 words, there's 1 space. If we have 3 words, there are 2 spaces. So let's figure out how many words we have on this line. Then we'll figure out how many spaces we have, and we'll just divide our number of gaps into, or by, the number of spaces we have. So let's do this first. So our word count, that's how many words are on this line. That's going to be our end index minus our start index. Now let's see, those could be the same. If we have 1 word, the end index and the start index will be the same, which in this case would give us 0 for word count. So we need to actually add 1. So if we have 2 words, our indices will just be 1 apart. So we basically have to add an extra 1 to get our word count. So for example, if end and start index are both 1, That means we have one word, the word at index 1, so we need to add 1 to our 0 here. So that's our word count. All right, now let's get our character count. We want to know how many characters we have for all of these words. So for this, I'm going to have to go through each word and sum up their characters. So for, it'd be nice if I could just do a sum. Let's change this. Since we're going to be doing this length calculation, so essentially I'd be saying for, I need to get the, or what would I do? Something like plus equals the length of our word for every word in, and then I have to do my words from my start index. I'm just typing this, even though I know it's not right, to my end index. So this is kind of ugly. I have to call this length function a bunch. Instead of doing that, let's just have one function up here that will go through, calculate all of our word lengths, then we'll just store those in an array, similar to our words. So the index of this word will also be the index into our length array. So let's do a word length here. It's going to be an array, and so word, and words, our word length, we'll just append the length of this word. Cool. All right, so that's going to help us out. Actually, that helps us out here too. See this word length, and we can just do word length. Instead of being a function call, this will be an index. We don't need to call words. I can just do end index. Awesome. And then that's going to help us down here. So our character count for all of these words, that's just going to be the sum of our word lengths from our start index to our end index. And now these ranges are not inclusive, and I do want to include the word at end index, so I have to do end index plus 1. Okay, so I've got the word count, how many words are on this line. I've also got the character count, how many characters are on this line that are taken by words. So now I can get my spaces count. Now the spaces count, well, that's basically our max width minus how many characters are used up by our character count. All right, so this is how many characters we're allowed. This is how many characters are used up by our words. So whatever's left, that's our space. So we have our spaces count, we have our character count. Let's see, I need to know how many gaps we have. So I'll have a gap count. So these are the gaps between our words. Well, that's going to be the word count minus 1. So again, if we have 2 words, we have 1 gap. If we have 3 words, there are 2 gaps, so on and so forth. So that's just the word count minus 1. Okay, now we'll calculate how many spaces per gap. This is a lot. All right, so how many spaces do we use per gap? So that's going to be our spaces count, integer divide by our gap count. Cool. So this should give us how many spaces we'll need or we'll use per gap. Now, if this is not evenly divisible, we might have some extra spaces. Let's keep track of our extra spaces here. So our extra spaces will just be, let's see, that's going to be our max width again. And we'll subtract our character count plus our spaces per gap count. Or no, our spaces, oh no, it's going to be plus the spaces per gap count. Oh man. Wait a second, I can do this without the max width. I just know how many spaces we have. So our extra spaces could be our spaces count. That's what I like better. So this is how many total spaces we're allowed, minus how many spaces we're using. And that's going to be the spaces per gap times the number of gaps we have. All right, so we have our spaces per gap. We'll just add each one of these between our words. With any extra spaces, we'll just add an extra space to our left words if we have any extra spaces. Now there's one other piece here that's a little bit different. If this is the last line, If this is the last line, we'll only have one space between words. That's what it tells us up here. If this is the last line, it should be left justified and no extra spaces inserted between words. So if this is the last line, we'll only have one space between words, and then we have to pad our ending with all the extra spaces. So we might have a little bit of extra work here. Let's do that here. If this is the last line, so if our end index, so that's our last word, if that is equal to our, I call it last index, yeah, if that's equal to our last index here, that means we don't have these extra spaces, and our spaces per gap will just be 1. So our spaces per gap, we're just going to have 1 space per gap, and our extra spaces, we're going to have 0 extra spaces. We're just going to put all these extra spaces at the end. Okay, so that's one sort of edge case. For all the other cases, we're just going to go through and add our words with these spaces in between. So for let's see, how do I want to do this? Maybe I'll just have some current index. Oh no, I'll just say for word. That'll be easier. All right, so for every word in our words list from our start index to our end index. Now I'm not going to include the end index right now because we're going to be adding spaces. Essentially, we'll take the word, add that to our line, and then add some spaces and move on to the next word, continue the loop. Now our end word will not have those spaces after it unless this is the last line. So we're not going to include the last word, this end index, in this loop. We'll have to handle it outside of this loop. All right, so for every word in our words from the start index to the end index, our line will just add, so plus equals the word. Let's see, plus some spaces. I'll just put that on another line here. Line plus equals. So we'll add the word and then we'll add the spaces. And let's see, what do we have here? We have spaces per gap, number of spaces. And so we have to multiply our empty string, or our space, by the spaces per gap. So in Python I can do this. In other languages you might have to do a for loop or something, but I can basically create as many spaces as I want by just having this space character times the spaces per gap. So we'll add that line. Now if we have extra spaces, so if we still have some of these extra spaces, we might have to add one more here. So if extra space, wow, this is going to use all of our time. So if we have an extra space, if it's greater than 0, we'll add this extra space to the line. So line plus equals 1 extra space, and then we'll reduce our extra spaces by 1. Awesome. Now the last thing, so I think this handles our spacing, except for our very last line. So for our very last line, we have, see, this extra space here, or it looks like if we have one word that doesn't quite fit, then we have these extra spaces at the end. So we might have to fill in that end with some extra spaces here. So let's just check. Let's just do a simple check. If the length of our line is less than our max width, then we need to fill in that extra bit at the end. So then our line will plus equals, we'll add some spaces, times, let's see, the max width, minus our line length. Okay, man. So this isn't particularly difficult. There's just a lot to it. Okay, I only have 2 minutes left, so let's just run this and see how we do. Okay, got something wrong. Char count reference before assignment, so let's see, where's that? Right, I need some basic char count here. And it's not going to be plus equals. That's my problem. So the character count is just the sum of the length of all these words. Try that one more time. Space per gap is not defined. Let's see, because I call it spaces per gap. Extra space, I think I called it extra spaces. Okay. We are not going to get this done in the Pomodoro. Oh, there might not be any gaps, so that's a good point. And we are out of time. Man, this one just takes time. So I'm going to push through. Hopefully you have time to view this. Let's see how we do. Okay, so how are we doing? We have this is, oh, but we're missing something here. We're actually missing words. Aha. You know what we're missing? We went through this loop, but we didn't include this last word because it doesn't have spaces after it. So down here, we do have to add that last word. So our line plus equals words at the end index. Let's see if that does it. And that works. Okay, let's submit this and see how we do. And we pass. We do all right. We beat 88% for runtime and 93% for memory. Wow, that's not bad. So I know we're way over time on this one, so we could go back and do a couple things. As you noticed, let's see, we're doing this length of word a couple times. Like this, we do line length more than once, so we could probably just do one line length here. Maybe I'll just do that really quick. So this might save us just a tiny bit. We could go through, clean up some of these names. We could probably do some better jobs with, let's see, what else could we do? I don't know, there's just a lot of code in here we could probably go through and clean it up. Let's see if this one change makes any difference at all. Not really. It actually gives us a worse answer. That surprises me. We're down to 63% and 69% for memory. All right. If you're interested, you can check out other people do it, but wow, there's just a lot of code in this one. It's even more code. Yeah, this just involves a lot of code. So I know we're way over time, so thank you for bearing with me on this one. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.